right, we are now looking at target 1.4, and our mastery learning objective is I can identify similar triangles using the AA, which stands for angle, angle, SSS, which stands for side, 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 and SAS, which stands for side, angle, side, similarity theorems. Okay? So we're going to be looking at, sorry, that's probably like crazy. We're going to be looking at 3 different things. Okay? We're going to try and get through as many as we can in these notes, and we might finish notes tomorrow in class. Okay? So first, our angle, angle, similarity. What all of these are is, so the other day we looked at showing that figures were similar. They needed to have their angles be congruent and their sides be proportional. Basically, these 3 similarity theorems or postulates make it easier. They're shortcuts. So before we had to show all 3 angles congruent and all 3 sides similar. Our angle-angle similarity tells us that if we just have 2 angles, then we know they're similar. So we don't have to do all the work. Nice. So, if 2 angles in one triangle are congruent, to two angles in another triangle, then the triangles are similar. Let's say congruent, but that is incorrect. Okay. So again, if you just have 2 of the angles, then we know that the 2 triangles are similar. So in this case, right, we have angle A and angle F. And we have angle B and angle G. So, triangle ABC is similar to triangle FGH. Okay? So again, similar to what we were doing in 1.2, but now we have like these, but these are just shortcuts. Okay. So there's a few things we need to know. So now we know that angles are the same. One of the ways we can know that angles are the same is the triangle angle sum theorem. The triangle angle sum theorem states that all angles in a triangle add to 180 degrees. Okay? So all the angles in a triangle add to 180 degrees. So if I know 2 of the angles, I can find the 3rd angle because I know it has to add up to 180. Vertical angles look like this. Right? And a lot of times we're dealing with triangles. This angle and this angle are vertical angles. Okay? So vertical angles are when 2 lines intersect angles opposite each other are congruent. Okay. So in the same way, this angle and this angle are also congruent, but these angles are not part of our triangle, so it's not as important as these angles. Okay? Alright, then we have parallel lines. Okay, when you have parallel lines, so something that looks like this, right? This marks that they're parallel, and then usually like we'll make a triangle out of them. And that makes like a nice triangle. When you have parallel lines, you have two types of angles. You have corresponding angles. So in this picture, we have corresponding angles. These two angles are corresponding. Okay, so with parallel lines, angles that are in the same corner are congruent. Okay, so if you see like these are both like above the parallel line and like to the right, above and to the right, so they're the same corner. Same thing over here. These are congruent because they're in like the same corner. So if you see these little parallel line marks, they look like little arrows, okay, then you have parallel lines. The other type of parallel lines you might see is sometimes they'll have like parallel lines like this, and they'll cross like this. Okay, this is our other parallel line. Then we have what we call opposite interior angles. They're both inside the parallel line, but on opposite like sides. Okay, so again, with parallel lines, angles that are inside but opposite are congruent. You did learn about these things last year in Math 2 Honors. But really, I'm going to be honest. Oh, and this one too, like these are also opposite, but inside. Okay. I'm going to be honest with you. I don't care if you know the name as much. I'll say it in class all the time, like I do with everything. But really the question I'm going to ask you is, are the angles congruent? Now, so much why. So as long as you know with parallel lines, we get these congruent angles, and you can say like, oh yeah, these triangles are going to be similar. Look at all these congruent angles. You'll be fine. Okay, so just know that you get a lot of congruent angles. All right, let's look at some examples of angles. Okay, so again, as I keep repeating, similar to what we did in with our 1.1, but now we're taking shortcuts. So I just need two angles. I don't need to show everything. So if I look here, I already see that angle L and angle M are congruent because they are the same exact number. Okay? But now if I look, J and P are not congruent, but I don't know anything about K or Q. So I'm going to find one of them. Let's find K. Why not? By using that triangle angle sum theorem. Okay, you could just as easily find Q. It doesn't matter. Just find one of your angles. Okay, so I'm going to say 57 plus 48 plus angle K has to equal 180 degrees. 57 plus 48, I'm going to combine those, is 105 plus angle K equals 180 degrees. Then I'm going to subtract this 105. So then angle K equals 75 degrees. Hey, look at that. Now this angle and this angle are the same. So I can say angle K is congruent to angle P. That's nice. One angle, two angles. Fabulous. I have my two angles, so I can say triangle LKJ is similar to triangle MPQ. And then I always want to say bi-angle angle. Okay? Alright, let's look at our next one. Alright, for letter B, we actually have all sorts of things here. I can actually prove that all three of these angles are congruent, but I don't have to. I only have to choose two. Well, the first thing I see is I have these parallel lines. Again, those parallel lines have the opposite angles when they're on the inside, when it looks like this. So here, angle R is congruent to angle W. In that same way, angle X is congruent to angle T. So that's because of those opposite interior angles. Okay? So now I have one, two, I guess I should say one angle, two angles. So I can say that triangle RX and then my S is similar to, since I went R then X, I should go W then T, right? And then it still needs an S. Again, bi-angle angle. Next problem. The first thing I see here is I have these right angles. Right angles are going to be congruent. So angle C is congruent to angle D. Then I need to find my missing angle. I'm going to solve for A. Remember, a 90-degree angle is a right angle. So I can say 90 plus 44 plus A has to equal 180. So 90 plus 44, that's what I'm combining. And we get 134. Then I have to subtract 134. And we get A equals 180 minus 134 is 46. Yep. Okay. Now look, this angle is not similar to congruent to this angle, and this angle is not congruent to this angle. Sorry. In this, I only have my one angle. I do not have a second angle. So these are not similar. Easy enough. right, our last example. Again, we have these parallel lines. And those parallel lines create those congruent angles. Angle J is congruent to angle P, right? And then I have angle Q is congruent to angle K. And look at that, I have an angle here and an angle here. So I have triangle J. I did these in the opposite order. Be careful, J, Q, K, L. And then I have to do B, P, Q, L. Make sure your angles are matching up by angle, angle. All right, go ahead, turn the page. Now we're going to try to get as much done as we can. The next thing we have is side, side, side similarity. So, another shortcut, but again, just a shortcut. Instead of dealing with angles, we can deal exclusively with sides. So, if all three sides are proportional, then the triangles are similar. Okay, so I got another shortcut. In 1.2, we had to check if all three sides were proportional and if the angles were congruent. Now, I can just check if the sides are proportional and be done. So now I'm determining whether these triangles are similar, right? This is helpful because I don't know anything about these sides. Or sorry, I don't know anything about these angles. So being able to just use the sides is really helpful, okay? I always start like smallest number over smallest number, middle over middle, and big over big. So if I look at my top triangle, my smallest number is 5. And so 5 has to go with the other smallest number, which is 12.5. And then that has to equal middle, right? And then middle number in terms of the actual order of the numbers. And then that has to equal our largest number and our largest number. Okay? Just so I know, those are the corresponding sides. Those sides have to kind of match up. When I use this calculator, 5 divided by 12.5 is 0.4. 6 divided by 15 is 2/5. And 8 divided by 20 is also 2/5. Now we have to be careful when we have a decimal because unless you're really good at fractions, you might not know if these are equal. So I'm actually going to convert these fractions to decimals. And how you do that is I can do 2 divided by 5. If I hit this control button again, right, and hit enter, it will give me that decimal. So 2/5 is 0.4. That gives me a side, and a side, right? So then, yay! I have to be very careful with how I set this up. I'm going to go P to Q, and then Q to R. So I went blue to red, so I have to go blue then red. So STR, right? And finish that triangle. So sometimes, like doing the different like symbols like I do is helpful. And then by, side, side, side. This video is getting long. We're just going to do one last example, okay? So again, I have 3 sides, so I'm going to try and do side, side, side. So I'm going to start with my smallest side over my smallest side. Sorry. And then my middle side over my middle side. And then my largest side over my largest side. Being very careful that everything on top comes from the same triangle and everything on bottom comes from the same triangle. When I reduce these, 8 over 6 is 4/3, 12 over 9 is 4/3, and 16 over 12 is 4/3. You can use a calculator to verify that. So again, I have side, side, and a side, right? So I am using side, side, side. So triangle, I'm going to do JKL. So I went green, then red. So green, then red. So triangle QPM. Side, 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 side. All right. I know this video is a little long. I apologize. We're going to finish up the side angle side in class tomorrow. Okay, so we'll do a little bit of notes in class, and then we'll jump into our activities. Have a good rest of your night.